this last talk tonight is about open source 5G edge automation via ONAP. And our presenter here is Amar Kapadia. Let me talk a little bit more about Amar. So Amar is a co-founder of an ONAP enthusiast at Arna Networks. And it's an open source software company providing a commercial distribution of ONAP. Prior to Arna, he was the NFV product marketing head at Mirantis. And before that, he was responsible for defining and for launching eVault public cloud storage service. They were later acquired by Seagate. And it's a product based on OpenStack Swift. So in total, Amar has over 20 years of experience in storage, server input-output technologies through marketing and engineering leadership position at Emulex, Philips, and HP. So Amar holds a master degree in EE from the University of California, Berkeley. Go Cal. Yes. So Amar, for you.
I have this one.
Yes.
Okay, yeah. Behind the podium?
Yes.
Okay, good. All right. So as we discussed, I'm going to talk about open source 5G and edge automation using an open source Linux Foundation project called ONAP. So this is a LinkedIn feed from this morning that sort of sums up why we are here. So this is Christoph, CTO at Swisscom, and he just came back from a 5G event, and he highlighted 4 problems. And I'm not going to go through all of them, but number 3 is automation, tooling, and end-to-end monitoring for virtualized network functions is not very needed to enable highly efficient operations. So out of the top 4 problems, 1 is about automation. So I'm clubbing all of that as automation. And so my response, you can see, ONAP Frankfurt released in first half should hopefully fill gap number 3. And then he went on to sort of say, yes, I also hope so. So that's why we are here. So I will throw out one caveat for the purists in the audience. 5G and edge are not the same, of course. You can have edge computing without 5G. You can have it with Wi-Fi. You can have it with wired networks. However, 5G does require edge. And I believe that edge will see a massive growth because of 5G. And so in my mind, they are sort of linked to each other, joined at the hip. So I'm going to sort of treat them together. So hope that's okay and the purists won't complain. This is not meant to be a 5G edge computing overview presentation. You probably have seen numerous, if not, there are hundreds of webinars and recorded videos you can watch on 5G and edge computing. But I'm going to sum it up in terms of how I view the technologies. So if you look at 5G, there are 5 technical differentiators and 3 business differentiators. And the differences between previous technologies and 5G are so big that you could almost call 5G a separate, different technology. It has nothing to do with 1, 2, 3, 4G. So from a technical point of view, there is enhanced mobile broadband that gives you up to 20 megabits per second peak bandwidth, so massive bandwidth compared to what we have, probably 10x. Ultra reliable, low latency, URLLC, that gives you extremely reliable sub-millisecond latency, something not even close in previous technologies. MMTC, which is IoT-centric, where you can have 1 million devices in a kilometer square. Network slicing, the ability to take a 5G pipe, carve it up into multiple virtual pipes, each with a different SLA. So if you have automotive, you could say, I want a network slice which is extremely low latency, I don't really care about the bandwidth that much, but I do want extreme reliability. While a CDN network slice might say I want extremely high bandwidth, no, I don't really care that much about latency, and yeah, reliability, give me the best case. I don't really care that much. So you can slice it up, which is again unique. Much longer battery life. They're talking about 5G IoT devices that can, on one battery life, can run for 10 years. On the business differentiator side, stack disaggregation. So if you look at 1, 2, 3, 4G, how do operators consume technology? They go to one large network equipment manufacturer and say, I would like 4G LTE. And you get their network functions, you get their physical boxes, you get their management, you get everything from that one vendor. Life is good. In 5G, for the reasons I will walk you through, you're going to have disaggregation. You're going to have industry standard x86 or ARM boxes. You're going to have containerized operating systems. You'll have Kubernetes. You'll have network functions and applications coming from all kinds of different companies. And for this reason, the stack cannot be monolithic anymore. Think of it before the iPhone, right? Before the iPhone, you would go to BlackBerry and say, BlackBerry, give me your phone, give me all the applications, give me the calendar that runs on it, give me everything from one. Now you would even almost laugh if you said, go to Apple for everything and get all the applications from Apple. It's almost laughable. So I think the same thing will happen here. B2B applications, again, when we think of 1, 2, 3, 4G, we think of a phone, right? That's what comes to mind. But 5G is so radically different that at least my prediction is that B2B will happen before B2C. So there's a lot of cost when it comes to B2C, and B2B just makes that much sense. And private. So far we have not had, there is private LTE, and in fact, there have been presentations at the out-of-the-box event, if you've attended them before, but it's not really taken off. Private 5G is expected to be extremely vibrant as a supplement to Wi-Fi. So things like factories, retail environments are expected to have private 5G. So for all of those reasons, you're going to see a lot of B2B applications. So on the right I have, if you notice, except for the last, they're mostly B2B applications. So smart buildings, where you'll be able to see things like space utilization, what actions are people taking, healthcare, where you'll have radiology, AI, ML being done at the hospital itself, innovative augmented reality, virtual reality applications for pain management, etc. Industrial, I've talked to several big industrial companies, and all of their major machinery is wired. With 5G, they expect it to be wireless, and analytics being done right there in the factory. Retail, that the only way they can attract customers back is if they make the retail experience exciting. Automotive, self-driving cars, and so on and so forth. Agriculture, and then entertainment. Entertainment is online gaming, AR, VR, immersive education, lots and lots of applications. Not just downloading Netflix in a couple of minutes, right? That's not the killer app. So these are the attributes, and these are the things 5G and Edge will enable. So from an automation point of view, it creates new challenges. There are many challenges. There are challenges on the radio, there are challenges on the network core, on the equipment. I'm not going to cover those. I'm going to focus on automation. So why does automation become difficult? First, you have a large number of edge sites. You may have tens of thousands, hundreds of thousands of edge sites where you have 5G radio area network functions and other applications that we'll talk about. Diversity of thousands of applications. So this is where my BlackBerry versus iPhone example comes in. Of course, you'll have network functions. You'll have radio area network functions. You'll have 5G network core functions, firewalls, et cetera, et cetera. But additionally, you're going to have analytics, AI, ML, inference engines, maybe some training in fat edges. You're going to have IoT management and microservices apps. Microservices apps is a catch-all for whether it's AR, VR, immersive education, any microservices application fits in that bucket. So you're literally going to have hundreds. So I attended a talk last week by Rakuten, where they talked about how they rolled out LTE in Japan, and they have 175 network functions. That's just for LTE. It'll be more for 5G, and by the time you start layering in analytics, AI, ML, IoT, microservices, you are going to be in the thousands. So you have thousands of applications that have to be pushed to these sites, highly dynamic environments, apps, because edge is fundamentally a constrained environment, you're going to have apps coming up, coming down, you'll have network slicing going on, you'll have radio optimization, application reconfiguration, there might be an AI ML application that needs a new algorithm, for example, so you're going to do all of this on the fly all the time. And finally, disaggregation means that you're not going to buy everything from one vendor, right? So the automation has to be independent of the application, and it has to be independent of the cloud. And all of this happens because 5G is going to be 100% software driven. So these are the challenges that show up on automation side. Now let's contrast them with the before. If you look at LTE, very straightforward. There were physical network functions, appliances, and you bought them from the same vendor. Like I said, orchestration, management from the same vendor. If you look at the cloud side of things, there is some level of automation going on, but not to the scale, not this level of distribution, not for these many applications, not for this level of dynamism. And that's why automation is a big challenge in the 5G edge world. So what does the requirement end up being? So on the top you have, I think the laser, I don't think the laser is working. So on the top you have the right to our cloud, right? You have the network core and a cloud data center or a public cloud. And on the left two are the edge clouds. So you have the network edge and on-prem edge. And these are actually, I believe these are Intel definitions, network edge and on-prem edge. So you see tens of public clouds, hundreds of network core, tens of thousands of network edge, and hundreds of thousands of on-prem edge. What do you have to do? First, you have to set up all the networks. I call it step 0 because that has to happen before you do anything with the workload. So that's a pre-step. Once that happens, you have to orchestrate thousands of applications. Now, these applications are not just going to sit on the edge. They'll span. Piece of that application might be on an on-prem edge, piece may be on a network edge, so on and so forth. So it's an N-tier application. And based on policies, you have to orchestrate. So one piece of the application might say, optimize for latency. One piece might say, optimize for cost. One might say, optimize for data locality. So you have to orchestrate an N-tier application across all these environments, honoring those business policies. That's just the beginning. Then you have to worry about things like traffic steering. Each application will have security policies that you have to push. There will be platform dependencies. So one application may need a database. One application might need Istio. One might need some security application. So all those dependencies also have to be orchestrated. And why is this the case? In a cloud, you have enough capacity. You can just orchestrate everything and everything is sitting there ready to go. The edge is a constrained environment, so we are going to bring up applications only when they're needed. They're not just going to be sitting there permanently. And day 0 configuration, so everything has to be configured. So that's the first step we have to do. Step 2, now that its initial orchestration is done, that's great, but now we have to do lifecycle management. We have to do ongoing configuration. We talked about things like network slicing, changing the algorithm on AI, ML. IoT devices will require lifecycle management. So there's ongoing configuration changes, change management, you have to upgrade, etc. And upgrading a service is very different than upgrading one application. If it's a service that's made up of multiple applications, there are dependencies, you have to do change management in a particular sequence. Cross-cluster scaling, if you have to move an application because the user moved, or you have to scale it across edge clouds. Network slicing we talked about, service authentication, and then finally termination, another very important task, termination and garbage collection. So that's lifecycle management. Then you get to monitoring and closed loop automation. So monitoring is just collecting all the telemetry, putting it up on dashboards. That's very common. There's n number of companies doing that for the cloud. But where it becomes unique for the edge is now you have to do real-time analytics, push the results of that analytics to a policy engine, and then the policy engine drives orchestration or lifecycle management. And that's what's called the closed loop. Why do you need a closed loop? Which human being is going to manage these number of clouds, our applications in these many clouds? It's impossible. So all of the management has to be done by machines, and that's where monitoring and closed loop automation is so unique for the edge, and nothing like that exists in the cloud world today. So these are the new requirements that come up for 5G and edge. And fortunately, you're thinking, oh my God, this is such a ridiculously hard problem to solve. Who's going to do this? Well, don't get stressed out. Fortunately, there is a solution. And that solution, as you might imagine, coming from me, it's ONAP. ONAP is a Linux Foundation project, 100% open source. It was formed as a merger of AT&T's eComp software, and OpenO was a prior project in the Linux Foundation. It was started by China Mobile, Huawei, and others. These two projects merged in 2017, and now the operators behind ONAP represent over 70% of worldwide mobile subscribers. So it has a huge following, as you can see. So what does ONAP do, and why do I feel it'll be successful? So ONAP has three components. It has an easy-to-use design studio for designing services that you push out. It has an orchestration and lifecycle management component to it, and a real-time policy-driven closed-loop automation. So those are, if you really look at a 100,000-foot level, those are the three things that ONAP does. Why do I think it'll be successful? ONAP genuinely has a number of architectural innovations. We'll look at a couple of, just 2 or 3 of those. It's 100% open source, so there's no vendor lock-in. It works great in this disaggregated world that I just mentioned. And there is momentum behind the project. You saw 70% of the worldwide mobile subscribers are behind this, or operators with over 70% worldwide mobile subscribers. And there is a network effect. Now, don't confuse this network for networking. What I mean by network effect is third-party open source and standard bodies look at ONAP as sort of the de facto open source project to work with. And as they work with ONAP, ONAP becomes the gold standard for those standards. And as a result, more third-party open source standard bodies adopt ONAP, and you get this virtual cycle. You get the same thing on interop side. Linux Foundation has an interop program called OVP. So VNFs will interoperate with ONAP. As more VNFs show up, more operators start using it, even more VNF vendors show up. So there's a couple of virtuous cycles going on here, and that's the network effect. And on standard bodies specifically, it's organizations such as ETSI, TM Forum, MEF, 3GPP, and other open source projects like CNCF. What is ONAP? This is from their website. So I'll let you guys just read it. I don't have to read it for you. So it's sort of what I just went through. But the interesting thing is the scope is quite large. It's for software, network, IT, and cloud providers. And it's physical and virtual network functions, and more recently, cloud native network functions or CNFs. So what does ONAP really do? So if you look at the ETSI framework, on the left-hand side, you have the data path. So you have commodity hardware, x86 or ARM servers, storage and switches, white box switches. On top of that, you have virtualization software, containers, VMs, virtual storage, overlay networking, data plane acceleration. And on top of that, you have platform services and workloads. There can be edge applications, analytics, network functions. And they are managed by Kubernetes or OpenStack. Those are effectively becoming the de facto standards. And you have many of those because each edge site will have that. Then you have centralized management and control plane. That's where ONAP comes in. So first you have the global orchestrator. In ETSI language, it would be called NFV orchestrator and MEC orchestrator, NFVO and MEAO. Then you have application managers, VNF managers, and MEC platform manager. And that can be part of ONAP or you can use external. It's really up to you. ONAP also has a global SDN controller built in. It has monitoring and closed loop automation. So everything in that red dotted line is the scope of ONAP. So that's why you'll see that oftentimes the ONAP community will resist using the word MANO, which is a common ETSI term for management and orchestration, because ONAP does so much more. And then on top of, you have, outside of this, you have OSS, BSS, e-services, big data applications. So we already saw, but I'll just sum it up. The scope of ONAP, again, at a very high level is you have a design framework and a runtime framework. Design framework is easy to use. It can allow non-programmers to use it. And the runtime framework, you have orchestration and lifecycle management. That's in black because that's what is specified in ETSI. But then you have two more functions. There's a monitoring and real-time closed-loop automation. That's extra. And then there is inventory service as well, where ONAP keeps track of all active and available inventory and all the relationships between the entities in that database. So it's a graph database, so that's available. In terms of an external view, that was kind of an internal view. From an external point of view, ONAP interacts with the cloud underneath it, or southbound, NFVI, or cloud as you wish to call it, OpenStack or Kubernetes. And above that, we already saw OSS, BSS, big data, analytics, and batch analytics, and e-services. And on the left, you have external modules and artifacts like application packages. Think of, so Nati Shalom from Cloudify summed it up quite well. Think of an application package as a remote control type of a thing. So it's the thing that tells you everything about the application, so that an orchestration software like ONAP can orchestrate it. And then you have a variety of other things that, that ONAP consumes in terms of artifacts and modules. So from a 100,000 foot level, let's dive down to like a 30-foot level. I'm not going to go through this, so don't worry. This is the official ONAP architecture diagram for the Dublin release and the upcoming El Alto release. El Alto should come out later this month or next month. And again, I'm not going to go through this, but on the left, the dark blue, you see the design framework. In the middle, the light blue, you see the runtime framework. You see something called OOM, that's to install and manage the lifecycle of ONAP itself. Below, you see the cloud itself, and there can be different types of clouds, multiple clouds. Hypervisor layer on top, OpenStack, Kubernetes, etc. Network functions, and third-party controllers. So that's ONAP in a nutshell. There's a lot of functionality, a lot of sophistication that has gone in terms of doing different types of orchestration, controllers, telemetry collection, analytics, and inventory services. So there's a lot of thought that has gone into these projects. So architecture principles, I talked about there's a lot of innovative architectural principles in ONAP. In interest of time, I'm not really going to go through all of them, but I would like to highlight three that I think, in my personal view, are the most important. The first is model-driven. Wherever possible, ONAP uses a model to describe whether it's a network function or an application or a workflow or a policy or a closed-loop automation loop. All of that is described as models. Now, why is that interesting? So first of all, now you can change the behavior of the platform without hard coding. You can use models, and models can be used to change the behavior of the platform. Second, you're decoupled from the release cycle. So you don't have to say, oh, I'm going to have to wait till El Alto before I can put in my changes. You can, with models, you can make changes anytime. Models are also amenable to the CI/CD flow, so you can have you can check them into a Git repo. Any change happens, you can trigger a CI integration cycle, testing cycle, CD. So they are very compatible with DevOps. So for those reasons, there's extensive use of models in ONAP, and I believe that's a huge differentiator/innovation. Cloud native. ONAP itself is cloud native. It's a containerized application, and ONAP expects the workload, which is the network function or other applications, to be cloud native. So there's a detailed specification that the ONAP community has put out in terms of what is cloud native and how should applications comply with that specification. And then the last is DevOps. So in the telco world, like everywhere else, you would do upgrades and changes every 18 months, or I'm just picking a time period, every certain years or months, and you would have a maintenance window and you would do your entire upgrade. With the new world, you're going to get network functions being upgraded at different rates. OpenStack, Kubernetes is going to get upgraded at different rates. So you can no longer do this nice 18-month thing. You have to keep updating or upgrading your cloud and your environment and your network services all the time. So that's the whole concept of DevOps and CI/CD. So ONAP uses a CI/CD mechanism to build itself, and it expects a CI/CD flow for the applications. So there are many other innovations, but I'm just highlighting these top three. So what are some ONAP differentiators? First is real-time policy-driven closed-loop automation. This is extremely powerful and unique, I believe, in ONAP. And with this, you can have fully automated management, and you don't require human beings. So administrators can now go from a break-fix mindset to a plan-build mindset, and only with this can you manage tens of thousands, hundreds of thousands of edge clouds. That's manual techniques just won't work. Simple to design, simple to use design tool. There's recognition that there are only so many engineers in the world, right? Software programmers. And so it's very important for this software to be usable by non-programmers. So a lot of thought and effort has gone in to do that. Global SDN controller has been integrated. It's actually open daylight. And what that allows you to do is not just do NFV services, but also NFV and MEC services, but also SDN services. So you can do the global connectivity between clouds, for example, using ONAP itself. NFVO, VNF Manager, MEC orchestration, MEC platform manager, all of that functionality can be realized through ONAP. It's a very powerful platform. You can literally, with models, you can literally make it do anything. It supports Kubernetes. I believe that's a big differentiator. Not just OpenStack is if there are any OpenStack bigots, pardon me for saying so, but OpenStack is yesterday's technology, and Kubernetes is the forward-looking technology. So ONAP does support Kubernetes. 5G use case, I'm going to talk about that, so hold on to that thought. And ONAP is open source. So for those reasons, I believe ONAP is unique and different than other equivalent software, proprietary or open source software out there. Now, one of the themes today is open source networking, right? So I'm hopefully these points have been covered, but if not, I'll quickly cover them. This is my view of why open source is so important for networking. So first, open source ends up becoming a partner to open standards. So ONAP, as I mentioned, is more and more becoming a reference implementation for open standards. I think that's probably one of the biggest value adds of open source. Second is a high probability of meeting operator requirements because there is, for example, in ONAP, there is an end user advisory group that heavily influences the direction of ONAP, which is very different than a proprietary product where an end user would have to go to a sales team would go to a product manager would go to engineering. Who knows what actually goes into the product? Here there is direct visibility. And by the way, the code, a lot of the code comes from, for example, AT&T. Assured interop, there's an interop program, so if something interrupts with ONAP, you sort of know it'll interrupt with commercial products based on ONAP. Faster innovation. So why do open source communities have faster innovation, right? The reason for that is you have diversity of experiences. So if you, for example, if you have someone who's great at automation and that person needs to talk to someone who knows hardware intimately well. In the ONAP community, you have that. So you can quickly, the two people can quickly talk and innovate quickly. In a proprietary product company, you would not have that diversity of experiences and things would just take longer. In fact, if you look at something called hardware platform awareness in ONAP, you will see that where hardware vendors, software vendors, operators work together and innovated, I would say, rather rapidly. Roadmap influence, that's similar to point 2. Reduced lock-in. If there are multiple products based on ONAP, you can switch between them. Transparency, everything in ONAP is transparent. What features are going in, what meetings, what were the meeting minutes, or you can join any meeting you want. What bugs are being fixed. The code itself, the testing script, everything is open. So you get tremendous transparency. And open source products are typically more secure than closed, again, because lots of eyes are looking at it and fixing things. So for these reasons, I think open source in networking is important. So now let's switch specifically to 5G and Edge. What is ONAP doing in 5G and Edge? There are 2 use case blueprints that I want to highlight. The first one is in ONAP, and it's called, aptly called 5G use case blueprint. The blueprint itself has 3 subcomponents or tracks. The first track is physical network function, discovery, and integration. And the main reason for doing this is the radio, as you know, is going to be hybrid. There will be some portions that will continue to be physical for performance and whatever other reasons. So for that reason, it's very important for ONAP to be able to handle a physical network function at the same level as a virtual network function. And ONAP does that, and that's the first track. The second track is network optimization. This is a big bucket of things, all the way from real-time analytics, where 5G network functions will be throwing out telemetry every minute or sub-minute, to bulk analytics, where they'll be throwing out information every 15 minutes, for example. So all of that telemetry has to be collected, analyzed, and the 5G network functions have to be optimized based on that fault and performance data. Homing, placing the right application in the right edge, that's what homing means. And homing could be, you could just say, I want the cell ID, something simple like that, or it could be something more sophisticated, like I would like this application to be on an edge cloud that supports DPDK, right? So that's the concept of homing, scaling and healing. You want to scale out your network functions and applications to keep up with the traffic, sort of capacity planning type. And finally, edge cloud automation. As edge clouds come up, you want to register them automatically with ONAP. Again, if you're, for example, I talked to one ride-sharing company, and they bring up 1.5 edge clouds per day. If you're going to have manual steps to register that with your automation tool, that's just too painful. So that has to be automated. That's the second bucket. The third bucket is network slicing. That's still in development. In network slicing, like I said, you have to take a 5G pipe and carve it up into virtual subpipes, each with a different SLA. And why is that challenging? It's challenging because you have to do end-to-end. You can't just, if you just have to do radio, network slice in a radio, that's relatively easy. But end-to-end network slicing is challenging. You have to create slices, configure them, optimize them over time. And that's being done in the ONAP community at this time. It's a multi-release effort. The effort started with the Casablanca release. And now we have Dublin and moving to El Alto and Frankfurt. So by Frankfurt release, which comes out in 2020, we expect the 5G blueprint to be complete and usable. So people will be able to take it into production at that point. And again, as I mentioned, I kind of warned you guys, this is not a 5G talk per se. So there is some nice 5G stuff going on, but I'm not really going to go through analyze a 5G network. And then the second blueprint I would like to highlight is in Akraino. If you attended the last talk, Ramki from VMware gave a talk where he sort of described some of this. Did anybody attend that last time? Okay, one. All right, so then it's useful to go through it. Akraino is part of Linux Foundation Edge. So Linux Foundation is organized in different umbrellas. There's Linux Foundation Networking, there's Linux Foundation Edge, so on and so forth, CNCF. ONAP sits in Linux Foundation Networking. So this is sort of a sister project, Linux Foundation Edge. And in Linux Foundation Edge, there's a project called Akraino. And Akraino is a sort of a meeting place where multiple users, vendors, technology providers come together and prove out edge cloud solutions that incorporate some Linux Foundation technology. All of it doesn't have to be Linux Foundation, but some of it does. So with that, what is this blueprint? This is a blueprint where some of the key members are Verizon, Intel, VMware, and Arna Network. So we are involved as well. You start at the OSS BSS. Below that, you have ONAP, which is the automation solution here. And we have chosen a subset of ONAP. And that's what Ramki covered last time in terms of what that subset is. Because we are doing a very specific thing, we don't need all of ONAP. So it's actually a vast subset of ONAP. And what ONAP is doing is it's orchestrating, managing, monitoring workloads that go on these edge sites. So what you see is two edge sites, Subscriber Edge 1 and Subscriber Edge 2. This particular blueprint does not have 5G at this point. I'm hoping that we'll do a variation of this that will have 5G. This one shows SD-WAN. So the network functions are SD-WAN related. There's VNFs and CNFs. VNFs are virtual network functions that are virtual VMs, and CNF stands for containerized network, cloud native network functions. They don't have to be containerized, but almost always they are. So CNF is essentially containers, VNF is essentially virtual machines. In addition to network functions, there are other applications that will be demonstrated in this blueprint. We are going to have a 360-degree video application to show a microservices application. For IoT, it'll be EdgeX Foundry, which is another Linux Foundation Edge project. And we are going to show some AI/ML inferencing. So that's all going to be shown. The cloud itself is going to be Kubernetes only, no OpenStack, just it's going to be Kubernetes. And there are, again, I'm not going to cover this ICN in depth, but there are some tricks that have been used so that Kubernetes can orchestrate virtual machines. So there are virtual machines, but there's no OpenStack, it's all Kubernetes. So that's ICN. So that sort of brings me to the end of the presentation. So please join us, and what can you do next? The ONAP project, you can go to onap.org, and that'll give you a lot of information on ONAP itself. The ONAP 5G use case blueprint, I've given the URL, that explains in detail what is going on with the 3 tracks that I mentioned, right? PNFs, network optimization, and network slicing. So it talks about all 3 tracks and what updates are occurring over different releases. ICN is in Akraino, wiki.akraino.org. And there again, you can see what's going on. You can join meetings. And one sort of shameless plug, if you want to do a free trial of ONAP, you can get it from our website. So with that, I would like to conclude and open it up if there's some questions.
Quick question. Do you know any?
Just a second, I'll be right over with the mic.
Okay, thank you. Do you know any carrier who has ever deployed ONAP in their field? Thank you.
There are, during the Dublin announcement, there were 3 operators that stated that they have put ONAP in production. First is AT&T, of course, and AT&T has both eComp in production, but they specifically made the point of saying that ONAP also is in production, because ONAP is open source and eComp is their own. So that's one. Orange has ONAP in production, and Bell Canada. So these are 3 companies, but if you look at the Dublin announcement that happened in June, there are at least half a dozen operators who are in POC stage.
Do they ever mention about the scale of their deployment?
I have not seen details, yeah. They've been kind of not very, they haven't disclosed those details.
Anyone else? Okay.
All right?
Thank you.
Very much.